In this video, we're going to look at work in a variety of situations and real world. So what is mechanical work? Mechanical work is done when a force makes an object displace. So in other words, we have to have a force and we have to have a displacement. And so you can see in our equation here, we have work equals force times displacement. And because force is going to be in newtons, and displacement is going to be in meters, our units are going to be Newton meters. Example. So we have a curler applies a force of 16.5 newtons on a rock and accelerates the rock from rest to a speed of 8.2 meters in 3.24 seconds. Assume the ice surface is frictionless and level. Determine how much mechanical work is done on the rock. So let's write down what we know. So we know our force, 16.5 newtons. We know we're accelerating from rest, so that must mean that our V1 is 0 meters per second. And we know our time is 3.24 seconds. And we know our V2 is 8.2 meters per second. And so it says determine how much mechanical work. So to figure out work, we need to do force times a displacement. So we have a force, so that's good, but we need a displacement. So we need to go and we need to look at our formulas and figure out which one we can use. So if you go and you look at your formula sheet, we don't have acceleration, and since we don't have a mass, that means we can't find acceleration. So we can't use one that has acceleration, so we're actually going to use the very first equation, which is our V2 plus V1 all over 2 times our delta t. So let's go ahead and put our information in. And when we do that, we get 13.28 meters. I'm not going to worry too much about directions or anything like that in this unit. And so now we have a displacement. So now we can go ahead and we can solve for work because we need to do our force times our displacement. So our force is 16.5 newtons, and we'll multiply it by our displacement. And we get 219.2 newtons. And now we're going to round. So we don't want to round when we get the displacement value. We want to round at the very end. So if we go back and look, we've got 3 sig figs, 2 and 3. So we want to round that to 220 newtons because we only want 2 sig figs. All right. So oftentimes that force is not applied exactly horizontal. So oftentimes we have an angle. So if you remember back to the first unit when we split vectors into their components, that's really what we're doing here. And we always want to go in the horizontal direction because if you look up here at that free body diagram, the normal force and the force of gravity often balance each other out. And in our situations, they're always going to balance out. So we have no displacement in the y direction. We only have displacement in the x direction. So when we do that, we're going to use this equation. And you're going to know you're going to use that equation because you're going to be given an angle. And so we're going to have to use a cosine. Example. So we have a suitcase being pulled by a traveler and it's exerting an applied force of 65.3 newtons. So let's write down what we know. And it makes an angle of 32 degrees with a level floor. And it moves 4.3 meters to the right. Calculate the mechanical work done. So we have our mechanical work equals F cos theta times our displacement. So that is our formula. So we have force, we have our angle, and we have our displacement. So we don't have to do any extra work here. We can just go ahead and put in our numbers. And then you can go ahead and put it in on your, so you get 238.12 joules, and then we're going to go and we're going to look. We're not going to worry too much about our angles for sig figs. We have 3, we have 2, so we want to round that to 2 significant digits, so we're going to round it to 240 joules. All right, so sometimes we have work in a positive direction and sometimes we have work in a negative direction. So the easiest way to kind of look at that is to go back to what we were just talking about friction. So we have a shopper pushing a shopping cart with a horizontal applied force of 43.2 newtons. And we have a displacement of 12.1 meters. And at the same time, the cart is experiencing a force of friction of 28.7 newtons. Calculate the total mechanical work done. So we want to know our work. So you have two options here. You could use this formula. So where you would go back and you would calculate your work, which again is calculated with F times D. So we could calculate, so we could do 43.2 times 12.1, that would give us our applied work, and we could do 28.7 times 12.1 to get our friction and then subtract them. Or we could solve for an F net first by doing our 43.2 minus 28.7 and so when we do that, we get 14.5 newtons as our force. So then we could just, instead of doing all the extra work, we could do 14.5 newtons times 12.1, and that did come out to be a positive value. So we get 175 joules. And if we go and we look, we have 3, 3, and 3 sig figs, so we're going to leave it at 175. So regardless of which way you do it, you get the same answer. So since we've just finished our force unit and we're pretty good at calculating net force, you could go ahead and do it that way. Or you, like I said at the beginning, you could do both of the work values. I believe your textbook actually calculates work applied minus your work friction. So you can see an example of that in your. So just one last thing before we finish off this video. Sometimes work doesn't work. So remember, in order for mechanical work to happen, there has to be a force and there has to be a displacement. So if we look at this first example here, so if you try and push a stationary car with a force of 300 Newton and it doesn't move, that means your D is 0. So if you sub in a 0 for your D, it doesn't matter how large a force you apply to it, you're going to get 0 joules, so you're going to have 0 work. So the other way this could happen is if no net force acts on an object. So if your net force, F net, if F net is equal to 0, then you'd be putting a 0 in for your force. Doesn't matter how far you move it, you would still get 0 work. So an example of that is just anything traveling at a constant velocity. So if you're traveling at a constant velocity, acceleration is 0. So F net, mass times acceleration, would be 0. So even if it's traveling, 100,000 kilometers, if it doesn't have a net force, it doesn't do work. So that's just been a quick summary of work. Hopefully you've found this to be helpful.